Okay, so today I'm going to be talking about the Earth and the Moon. This is located on day 4 of your guided notes. So first, where did the Moon come from? All right, we don't know exactly for sure where the Moon came from, but one of the biggest ideas is called the giant impact hypothesis. All right, back when the Earth was first being formed, when the solar system was being formed, there wasn't an Earth and a Moon. There was just the guess was there was just this one large object that had all of the matter of both the Earth and the Moon. And then at one point in time, an object which is estimated to be about the size of Mars came crashing into that object. After that collision, there's a tremendous amount of dust and debris that was blown out of the side of the object. All right, so all of that dust and debris went out into space and eventually clumped together through a process called accretion, and that is how it is explained that our moon was formed. All of that dust and debris suddenly came together through forces of gravity to make the moon. So something that you probably already realize is that the moon goes around the Earth. All right, more technically, they go around each other. All right, through that phenomena called a barycenter. All right, but since the Earth is so much larger than the moon, it looks like the moon is doing most of the revolving, and the Earth pretty much stays in the middle. All right. So the path that the moon takes around the Earth is an ellipse, and that's the same as the path that the Earth takes around the sun. All right, and whenever you have an elliptical orbit, there's going to be a point where the object is closest to the center object, and there's going to be the point where it's furthest away. All right, and we had names for both of these with the Earth around the sun. There's also names for these points with the moon around the Earth. All right, the point where the moon is closest to the Earth is called perigee. All right, which sounds a whole lot like perihelion, which was the name that we used when the Earth was closest to the sun. All right, the name when the moon is furthest away from the Earth in its orbit is called apogee. All right, which looks like aphelion, which is the name when the Earth was closest to the sun. All right, so it's known that the amount of time that it takes for the moon to go around the Earth just happens to be the exact same amount of time that it takes for it to do one spin. All right, so the moon spins on an axis just like the Earth spins on an axis. All right, the difference is instead of it taking a day for it to make one of those spins, it actually takes 27 and a third days for it to do a spin. And since that's the exact same amount of time that it takes for it to go around the Earth, you only end up seeing one side of the moon. So if you've looked up at the moon at night, I'm sure noticed that it has different appearances over different times in the month. All right, this is the one that a lot of you would be familiar with. You'd say that is a full moon. All right, so the names of these different appearances are lunar phases. All right, and they're the result of the motion of the moon and the sunlight that is reflected from its surface. All right, so one thing about the moon, all right, if I were to say how much of the moon is lit up, all right, it is always one half of the moon. What causes the phase is what part of the moon are we looking at. All right, so when you have a full moon, all right, this is the half of the moon that's lit up, and it happens to be the half of the moon that we're currently looking at. All right, when you look at this right here, this side of the moon is lit up, but there's a part on the back side over here which is also lit up. All right, so the right side is lit up, the entire left side is dark, but since we're looking at it from the side, it appears to only have half of it lit up. All right, so there are names for all of these different phases. We're not going to go through them all right now, and we will be also doing a little demonstration to show why you get these different appearances But for now, make sure that you have this in your notes. So, solar eclipse. Hopefully you've heard of a solar eclipse. All right, so a solar eclipse happens when the moon gets in between the sun and the earth. All right, so if we were to be looking at the sun, normally it's out there and it's visible, but if the moon was to pass directly in front of the sun, which doesn't happen all that often, you would have what's called a solar eclipse. All right. One of the things that I want to point out about this image right here is one of the layers of the sun that we talked about before was this layer called the corona. All right. And if you see this bright glowing area right here, you can't normally see that. The reason that you can't normally see that is because the photosphere, the part that normally you can see, is so bright that it drowns out the light that's given off by the corona. All right, but if you block out the middle of the sun with the moon, all of a sudden that corona becomes visible. All right, so since this is a blocking out of the sun, it has to happen during the day. All right, because that's when the sun is going to be visible. All right, so in contrast to a solar eclipse, a lunar eclipse is when the Earth gets in between the sun and the moon. All right, remember that the Earth is a lot larger than the moon. All right, so for that reason, lunar eclipses are actually a lot more common than solar eclipses. All right, so lunar eclipses happen when you have this orientation right here, and what ends up happening, just like anytime you have a light and you put something in front of that light, it's going to block the light. It's going to cast a shadow. So if the Earth is right here, the Earth is going to cast a shadow in front of the moon. All right. So this right here shows a little bit what it looks like as it gets in front of the moon, in the way of the sun and the moon. It casts that shadow, and you can see that shadow being as it passes in front of the moon. All right. So because in order to see this event, you'd have to be on this side of the Earth looking at the moon. It would have to happen at night. Okay, so one important thing that the moon causes to happen to the Earth is the tides. All right, so tide is essentially the rising and falling of sea level that happens over the course of the day. Right, when you have high tide, the water comes towards the shore. When you have low tide, the water moves away from the shore. All right. So essentially what happens is when you have the moon out there, the moon is going to exert some gravity on the Earth. All right. And what that does is it pulls on the Earth wherever it can. All right. The thing about the land is it's a hard, solid material. And if that gravity pulling on the land can't really pull on that solid material that well. But water is liquid. All right, and when that gravity pulls on all that water in the Earth's oceans, it causes a little bulge in the Earth to go this way. All right, so this little red, this little oval right here is really, really exaggerated. All right, the actual amount that the water is going to be pulled from the surface of the Earth is only going to be about 10 feet or so, all right, 10 to 20 feet. And 10 to 20 feet compared to the size of the Earth is pretty small. So you wouldn't even be able to see that difference from space, all right? But when the moon is here, you're going to have the Earth is actually going to be slightly wider in this direction, the direction that's towards the moon, because the water is being pulled that way, all right? You're not going to notice it any higher over the land areas, but you would notice it in the oceans. All right. One thing about the tide is that you not only get when it's high tide, you not only get it not only gets bigger in this direction, but it also gets bigger on the opposite side. All right. These are called the tidal bulges. All right. So you get a tidal bulge towards the moon. You also get a tidal bulge away from the moon. All right. If you were at a beach right here, you would have high tide. If you were on a beach right here, you would have high tide. All right. By contrast, if you were on a beach right here, you would be having low tide. All right. And if you were a beach down here, you would also be getting low tide. All right. So Remember that the tides are caused by the moon's gravity on the Earth.